been reviewing for our exam. There she is. Well, I went to click on her and she was gone. I don't know. Maybe she'll come back. All right. We are reviewing for our exam. We are on page 596, which is some stuff from chapter 4. We're going to go over that. Then we're going to move on. Stuff from chapter 5, chapter 6, etc., and keep going through. Like I said, I'm focused on the review problems that I know are like problems on your exam. So if you follow along as we're doing these reviews and you keep your problems, now if you just copy down the answers, is that going to help you? No, you need to actually have the work on there or pay attention. Like on today, on some of them, we're using a table. So I'm telling you what page that table's on. So you may want to write that down for those type of problems so you know where to look when you're working on your exam next week, okay? So we're on page 596. We're starting with number 11. I would ask for you to work through some of 1 through 10 on your own other day, especially because I went over like your distance formula and that kind of stuff. But I'm going to focus on these to make sure I get through these together with you, and then we can go back and talk about them if we still have time. So on here, on number 11, our directions say write the domain and range of each function in interval notation. Okay, now we talked about domain and range in chapter 4, and I put up here that it's on a table on page 186. So before we go anywhere else, flip back to page 186 after you got your problem written down. Okay. We have a table on page 186 that has our domain and range rules for all of our different types of functions. So basically, you have to be able to look at the problem, figure out which one of these types of functions it is on the left-hand side, and then follow the guidelines it tells you for the domain and the range. Okay, so for number 11, my function is f of x is equal to x minus 6. So it has an x and then a number. So which kind of function does that look like on here? Linear, constant, absolute value, which ones does it look like? It has a single x without a
Linear.
So it's a linear function. So if you look at the linear function, it tells you for all linear functions, your domain is all real numbers, which they show that by going from negative infinity to positive infinity. And your range is also all real numbers. They show it goes from negative infinity to positive infinity. Because remember, a line goes on forever. We always put the arrows on each end to show that it continued on. So since it's going on forever, that's our domain and range. Negative infinity to positive infinity. Negative infinity to positive infinity. Because this one was a linear function. Okay? Now, this next one that I have just says f of x is equal to 12. So if you look on there, which one is it like? Or it's just equal to a number?
Constant.
Constant. So if it's a constant function, if you go over to the column, it says the domain is still going to be all real numbers. So my domain is still negative infinity to positive infinity. But my range is just that constant number. Now you'll notice that they wrote it twice inside of brackets, because that means the highest y value you have and the lowest y value you have are that number. So it's just saying it's going from 12 to 12. Can't go anywhere else. Okay? Now, if we look at this one, which type of function is it?
Rational.
Rational. Okay, so it's a rational function. So we got to read our rules for that. On the rational function, this one was a little bit more complicated. Okay, it says on our domain, it's all real numbers except when the bottom is equal to 0. Because can you have 0 in the denominator of a fraction?
No.
No, we can't. So what we got to do is we got to set that bottom equal to 0 and see what number it cannot be. So we take x plus 6 equal to 0. We solve to get x by itself. And so it's x equal to -6. So it can be any number at all except -6. So now we're going to write that as it goes from -infinity to -6, but it doesn't include -6 because I put parentheses. If it includes the number, remember, we put brackets. We talked about interval notation again yesterday. And it goes from -6 to +infinity. Now for my range, it says it's all round numbers except the ratio of the leading coefficients. So my leading coefficients are the two numbers in the front here, okay? So what's my ratio of 6 over what's here if there's nothing written?
1.
So 6 over 1 is just what? 6.
Yeah.
So our range value can be any number except 6. So it's going to go from -infinity to +6, from +6 to +infinity. Okay, so that's the table that you will use for some of those. When it's talking about finding domain and range of the functions, you have to identify what type of function it is and then state the domain and range. Okay, pretty easy, especially if you're looking at your table. All right. Now, the next one that we have that we were going to talk about is on the same page down farther for number 21 and 22. Now, this is something else that you have. There's like 4 or 5 problems that deal with this on the exam. Okay. I believe it's a matching section. Okay. So you've got to know what they match up to. Again, I told you a table that we're going to refer to because our directions say for 21 and 22, determine if the graph of the function will have a vertical translation or horizontal translation, a vertical reflection, a vertical stretch, or a vertical compression. So these are the ones, remember, we're looking at the basic quadratic function or quadratic equation, and we're trying to figure out where it is moving the graph on the coordinate plane. Translation is just sliding it over. So if it's talking about vertical, we know that's going up or down. If it's talking about horizontal, that's going left or right. A reflection means it takes it and it flips it over. Stretching means it's going to make it skinnier and taller. Compression is going to make it shorter and fatter. Okay, so we're looking at the table on 205 for these. I'm trying to get my pages turned. All right, so we have a table down at the bottom of 205 that talks about transformations for translating graphing of quadratic functions. Now, you've got to remember your basic quadratic function. Our basic quadratic function is equal to a as the number out front, and then you have x minus h in parentheses squared plus k. That's your basic formula, okay? And then it tells you in the table different things that tell how that equation is going to be moved. So we have a vertical translation. It's going up or down if it has the plus k part, something either added or subtracted to it. So if it's added, that means it's going to go which way? Up. If it's subtracted, it's going to go down. Okay? So on number 21 to start with, I have my x squared part here, and then I have the -4. So I know it's going to have a vertical translation because it's going to go down 4 units. Okay? So I know that's one of the things it has on there is a vertical translation. Now, another thing that we have to look at on here is when it has a horizontal translation according to the table. It has a horizontal translation if you have something in the parentheses with the X. So does this one have anything in parentheses with the X?
No.
No.
Yeah. So it doesn't have a horizontal translation. What about number 22?
Yes.
So we know this one has a horizontal translation. Okay. Now we got to see what else we have. The next thing that talks about in the table is a vertical reflection when it's flipping it over. So when it's flipping it over, you'll notice it just has a negative in front of the x squared. Do either one of these have a negative in front of the x squared?
Yes.
Yes. This one has a negative in the front. So this one's also going to have a vertical reflection. Okay. Now, the next thing it has on there is a vertical stretch. The vertical stretch is when you have a number in front of x squared and that number's absolute value is greater than 1. So does this have a number in front of the x part?
No.
Does this one?
Yes.
Yes.
Is the absolute value of 3 bigger than 1?
Yes.
So it's going to have a vertical stretch. It's going to stretch it up taller. Okay, it's going to make it skinnier and taller. Your parabola. Okay, and then like the one right up here in the example above it, that's what they had. Then the last one's a vertical compression, and that's when you have a number in front of the x squared that's absolute value is less than 1. So that would be if you had a fraction or a decimal like 0.5 or 2/3, something like that in front of the x squared. And neither one of those have that. Okay, so this table, page 205, is something you're going to need because I told you you have like a whole little section of matching these. So what it's going to do is it's going to give you an equation and then you're going to match it with what's being done to it. So if I just told you y equals 5x squared, okay, from what we just talked about, if it has 5 in front of the x squared, that means it's a vertical stretch. So you would match that one with vertical stretch. If it said y equals, if it just had that part, not the negative, just that part, then we know that was a horizontal translation. If I had y equals x squared plus 3, y equals x squared plus 3, what type's that going to be?
Vertical translation.
Good, good. A vertical translation. Very good, because you just have the x squared plus the number, okay? So that's that's like 5 problems right there on the test, is using that table, knowing which type it is. Okay?
So any tables you give us, we can use it on chess.
Oh, yeah.
Okay.
Yeah. And the thing is, I mean, because you're allowed to, I'm letting you all use your book and stuff. You're going to be on Zoom, so I can tell if you're like totally off base, not even on there, but I'm trying to tell you where the tables are so you can use them, because I let you use them when we were doing it, when we did quizzes and stuff, or you had your notes that had it on there. But any of the notes that you have that you took when we were still here in school, any of those you're allowed to have out too. Okay, it's just, it's easier to have it like on notes or the examples that we're doing now, and only have to turn to your book for a couple of tables instead of trying to hunt through the entire book, because we've covered the entire book trying to find stuff when you're limited your time on your exam. So that's why I'm trying to pinpoint and tell you where the tables are so you know, okay? Because you don't have time to be flipping through everything in here. All right. Now, does anybody remember what these things are called?
Matrices.
Ooh.
Matrices. These are what we did right before spring break because y'all thought they were easy. Remember, we like those. They were easy peasy. Okay, so we're going to talk about them a little bit because there are a couple of matrix problems on the exam. Okay, so starting with these, the first problem that I have is adding. This is on page 597 now down here at the bottom because this is stuff from chapter 6. Okay, notice I didn't talk about anything from chapter 5 right now. We'll worry about that on one later. Okay, so on here we're working on these. When you are adding, remember when you're adding a matrix or subtracting a matrix, you have corresponding elements. The numbers inside the matrix are called the elements. Corresponding means they're in the same position. So those are the ones that you add or subtract together. Okay, so I'm going to add the 11 with the 0. I'm going to switch markers because that one, I'm not caught cap off too long. It said, I can't write anymore. All right. So I've got 11 and I've got 0. So 11 plus 0 is 11. Okay, I'm trying to get where you all are, the glare is not right on there. It's over the plus sign, you know it's a plus sign, so we're good. All right, so the next one has 8 and -2. They're in the top right corner in both of them, so they're corresponding, they're in the same spot. So 8 plus -2 is 6. Then I have -3 and 15. When you add a negative and a positive, remember you subtract. We get 12. And then my last one, I have -1 and 17. So I subtract and get 16. Just add the corresponding elements. If it was a subtraction sign, you would subtract. Same thing. Numbers in the same position correspond to each other. Now, on number 3 and number 4, it says to multiply them. We're not actually multiplying because you don't actually have to multiply it out on the exam. Okay? You all did not like the multiplying ones at all. Because remember on the multiplying, you had to go like across the row and down the column, and y'all didn't like that. Remember, we had to go like across each row in this one, and then down each column in this one. As we multiply and you get big long thing. We didn't like that. The only thing you really need to know from that for the exam is if you can multiply them or not. Okay? And how big your answer would be, your product would be. So the way we do that is this has how many rows? This first one in number 3 has how many rows? Remember, rows go across. So it's got 3 rows that go across, and then it's got 2 columns. When you are saying your dimensions, it's always rows by columns. This one has how many rows?
2.
2 rows, and then 1, 2, 3 columns. So when we go to try to multiply these, we have something we always have to check and see if it matches up. This and that have to be the same in order to multiply. The number of columns from the first matrix and the number of rows of the second matrix, the 2 inside dimensions have to be the same. Then your product will be the size of the ones left over. So it will be a 3 by 3 matrix for my answer.
So if they're not the same, you don't multiply.
Huh?
If they're not the same, you don't multiply.
If these are different, then you just say you can't multiply. Okay? So, but that's what it wants to know. It wants you all to be able to say, yes, you can multiply it, and if you can multiply it, you're going to tell the dimensions of the product. So on this one, what are the dimensions of the first one? There's 1, 2, 3 rows, and just 1 column, right?
Mm-hmm.
This is what they call a column matrix because it only has the one column. This is a row matrix because it has only the one row. It's got one row, and it's got 1, 2, 3, 4 columns. So my answer is going to be, first of all, can I multiply them? Is this the same?
Yes.
Yes. So we can multiply it, and it's going to be a 3 by 4 matrix. That's what it's worried about. It's not actually making you multiply it out. It wants to know if you can multiply it and what the dimensions of that product would be. Okay, so that's all you have to know as far as you got to be able to add or subtract them, corresponding elements. You have to be able to determine whether you could multiply or not. And if you could multiply the dimensions of the product. Okay, so that part pretty easy. Now we had one more thing we were going to talk about with our matrices, and that was problem number 9, which you have to turn the page over to page 598 for it. Okay, on problem number 9, it asks for you to find the determinant, which you all thought this was pretty easy too. For your determinant, okay, for the determinant, this is the word I'm saying, it's here in your book in the directions. Basically, you cross multiply and you subtract. That's how we found the determinant. We did this like that Wednesday, Thursday, right before you all were out for spring break, and then you never got to come back. So we label this. This is A, this is B, this is C, this is D. So what you do is you multiply A times D, and then you subtract what you get when you multiply B times C. You're just multiplying diagonally. So I'm taking 2 times 6 minus B, which is -4, times C, which was -3. You just subtract those and see what it's equal to. That is your determinant. Okay, so what is 2 times 6?
12.
12. What is -4 times -3?
-12.
No, what's a negative times a negative?
Positive.
Positive. And then 12 minus 12 is 0. But that's how you find the determinant. You multiply diagonally and subtract the two products. Okay? But there is one that's like that on the exam. So you do A, you multiply top times bottom, minus bottom right times top right times bottom left. Okay? All right. Next one. We are flipping over. No, we're on the same page down. We're just farther down. Yeah, we're skipping down. We're on chapter 7 now. Chapter 7 down here at the bottom. This is when we talked about logarithms and exponential functions. Logarithms and exponential functions. Okay, so remember we have a basic thing for our logarithms. Okay, in chapter 7, we have our basic rule for these. You should have it like in your notes because I wrote it down like 20 million times when we were doing these. Okay, with our basic. I was trying to find what page it was on to tell you all. Okay, There it is. I know I'd find it eventually. All right, so it was down here, the main rule that we used over and over. It was on page 340. Okay, and with that, y is equal to log b of x. Okay, that's our basic one. All right, now with this, that is the same as x being equal to is that right? I can't see.
Can't see it. It's a glare.
So I know this is that better? All right. So that's where we're at. All right. So remember on these you have your base, you have your exponent, and you have the one thing they answer. This thing right here is called your, does anybody remember the word for that? This is the base. This is the exponent. This is what we call the argument. Does that word sound familiar?
Mm-hmm.
You fought with your parents, but an argument, okay? A math argument, not a yelling argument, okay? So these are our basic things for this that we're going to use for 5, 6, 7, and 8. Okay, now the natural logarithms are a little bit different, but it's still the same concept, and you'll see that in a minute. Okay, I'll put that one up here too. But let's do 5 and 7 first because they're using this. Okay, remember this raised to the power, that's our b, and this is our exponent, our y. So when we go to rewrite it like this, remember this is our b, this is our y, this is the x, the argument. So now I'm just translating it into this form. The y goes first, so I have 3 equals log of the base, which was 4, and the argument 64. Now, when you are rewriting these, you have to be careful that your little thing down here looks like a small little 4, that it doesn't look like 464 if you're writing it down. Okay, it's a subscript down below there. Okay. So on your note, make sure you're writing it down correctly. Now on the test, it'll have that like multiple choice, so you pick the right one. But you still have to know that you're picking the right one. Now, that was taking the exponential equation and writing it as a logarithm. Now on number 7, I said we're going to skip and do that one first because it's using the same one, and then we'll talk about the natural logs. We have log 2 of 128 equals 7. So this is the same thing as this up here, okay? They just switched what was on the equal side. This is still the little b, this is still the x, and this is still the y. So we translated into this one. So the translated into this one, the x goes by itself, 128, I'll switch markers, I want the black one for that. 128 equals the base, which was 2, to the y, the 7th power. So basically what this means, if you take 2 to the 7th power on the calculator, it equals 128. Okay, now for your exponential ones, like I said, they're a little bit different. It talks about them on the next page, I believe. Okay. On them, you have E, which is Euler's number. so you have the natural log of x. Okay. So bad. All right. So we have our natural log of x. Sorry, you all. I have an ant bite, so I'm still itchy. All right. Well, apparently she's not going to get on again today. Okay, so we're doing the same thing for 6 and 7, right? Except they're natural logs. I lost my page. Sorry, I'm trying to find a page number again. I flipped back to the one page and I couldn't get back over. All right. I couldn't find it. Okay, so what we're doing on these is this the same concept. This is ow. This is your exponent, right? Your Euler's number is like your base, and then this is your argument. So even though this is an x, this is your exponent. So it's kind of similar. This is your base. This is your argument. So, but it's a natural log. So we'll have our exponent like we did here. The exponent. I keep doing that one. I don't want that one. Put it away. All right. Our exponent x is equal to, remember, instead of log, it is ln for natural log. And then you have your 18. Your argument. So it's pretty much the same thing. This is your exponent. This is your y. This is your argument. This is your base. So it's like this still, it's just it's got an e for the base instead of some other number. So on this one, our base, remember, is going to be e when it's a natural log. This is my argument. And then this is going to be my exponent. So I'm going to have 20 to the what? E to the, I can't read my own right now. E to the x, your base to the exponent is equal to the argument. That's those. All right, I'm putting this other marker over here so I don't keep grabbing it. Because I keep grabbing it and it don't work. All right. So, remember, they're multiple choice. So if you know this basic about what the argument is, the base and the exponent, you should be able to figure out those, which one's the right one. Okay? Now, for the next one, number 9, it talks about, it's on the, you actually flip the page, it's at the top of page 599. Okay? On the top page 599, it says, evaluate each logarithm using the change of base formula with a calculator. Round answers to 3 decimal places. So it specifically talks about the change of base formula on your exam. It asks about it specifically in a problem. So you gotta know what that is. Remember in this is my base. Okay, I'm from this up here. Okay, remember this right here. This is the base, this is the argument. So on here, this is my base, this is the argument. For the change of base formula, that is equal to the logarithm of the argument over the logarithm of the base. So in this one, it's going to be logarithm of 14 divided by the logarithm of 3. Now, on your calculator, you have the little button up there that says log. So that's what you would use now. You're going to type in log 14 divided by, oh, you got to close parentheses. I forgot it does parentheses on here. Divided by log of 3. You get big long decimal. It said how many decimal places?
3.
3. So my answer is going to be 2.402. So you just need to remember for this right here, this is called change of base formula. Okay, so when it talks about solving by change of base, that's what it means. Okay. Now, our next one that we have, number 12 and number 13, are talking about expanding the logarithms and condensing the logarithms. Now, we had rules for these. Okay, they were pretty easy. If it has multiplication, to expand it, we change it to addition. If it has division, you would change it to subtraction. Okay, if you have an exponent, it ends up going to the front. Okay, so when this one, we have two things next to each other, so it's multiplication. So we're going to start off, we're going to have log w to the 4th plus log z to the 7th. We just separate it into the two separate parts. To expand when it's multiplication, you change it into addition. Now remember, we don't like this exponent on our argument here, so it goes to the front of that part, and this one goes to the front of that part. So I will have 4 logarithm of w plus 7 logarithm of z. Does that look familiar? Most of you all like this part. You thought they were pretty easy. Does it look familiar? You remember it?
Yes, ma'am.
Okay. Most of you, like I said, you thought this part was pretty easy. Now, on number 13, we're just going backwards. Okay? You can tell it's already been expanded, so I got to go back and what they call condense it. Okay? We're going back and condensing it. It's the opposite of expanding. So the first thing we do is we work backwards. So if we got a number in the front, we send it over here as an exponent to begin with. So this will become log 2 of x to the 9th power plus log 2 of y to the 10th power. Okay, now you'll notice on these, my logarithm has the same base, so it should. That's what we're going to have in our answer. Now I have log with a base 2 of, and then I just write these right next to each other, x to the 9th, y to the 10th. So that's condensing. And you do have questions about the expanding and condensing on the exam. Okay. It says which one of these expanded the logarithm correctly. You pick the right one. Or which one of these condensed the logarithm correctly. You pick the right one. Okay. A lot of the questions are multiple choice. So if you know the basic rules, then you should be able to figure out which one's the correct one. Okay. Now, for the test, okay, let's see, covered that. Okay, the next thing that we're going to focus on, the next part that we're going to focus on is our trig stuff. And basically, remember with that, we had the 4 quadrants. Remember the ASTC, does that sound familiar? ASTC? All of them were positive, just sine was positive, just tangent was positive, just cosine was positive. So we're going to talk about a couple of questions with that, not many because there's not a lot of that on the test. And then we're going to spend more time focusing on our probability stuff, our permutations, combinations, and our basic probabilities. because there's more of those on there. Okay, so that's what we're going to be working on mainly tomorrow, is our ASTC stuff, our basic sine, cosine, tangent. Okay, and then our probability stuff. So basically it's stuff from like chapter 8 and 9, and then we'll be working on skipping to chapter 11, I think, was our probabilities. Okay, so that's what we're going to be doing tomorrow, and then we'll see what else we still need to cover on Tuesday, because Tuesday will be your last review day, because your all's exam is when?
Wednesday.
Wednesday. Now remember, our schedule starts being a little different starting tomorrow. Okay? Now, you all first thing in the morning tomorrow get to take your lovely physical science exam. It's like 80 something problems, I think, because I gave it last year when I taught it in North Florida. Okay? So you have that exam first thing. After you have that exam, then you have a little bit of a mind break, and then you're taking your literature exam with Miss Vargas. And then you have lunchtime, and then you come in here and we review. Okay, so that's tomorrow. Now, remember, you have a little bit of extra break between your science exam and Miss Vargas, because instead of starting at 11, you won't start till 11:15, because I was trying to give you a little bit extra time to recoup from one exam before you do another one. Okay, then next week on Tuesday, I'll still see you at normal time, 1 o'clock in the afternoon, for our review, but you'll have your, so you won't have as many classes. Your stuff will be later on Tuesday. It looks like on Tuesday you all don't have anything till like 11:15. Oh, look at that. And then you'll have review with Miss Vargas for grammar then, and then you'll have review with me at 1. And then on Wednesday at 9 o'clock in the morning, you'll take your Algebra II exam, and then that'll be the last time you log in with me, is next Wednesday. Okay? Then you'll be done with Algebra II, if you've got all your stuff turned in. I've been trying to send emails and stuff, some of you that were still missing some quizzes or whatever. Some of you, I'll have some things reopened on ProProfs over the weekend. So it's very important that you check your message tomorrow. And my school works like tomorrow afternoon. If I'm telling you, hey, you need to go take quiz 45, or you need to go take whatever it was, okay? And then don't forget, if you were gonna do extra credit, I'm supposed to have that by tomorrow, okay? So you can still turn that in. And I think that was it. We're almost done. You have basically 3 more classes in your exam with me. Okay, so make sure you know if you got to work on stuff, you're getting it done. Keep trying to work on this reviews pages and see what you remember on your own, just because that's good. That helps you. And make sure you don't lose any of these that we're doing together, these special pages I'm telling you for tables and stuff, so you have them for your exam next week. And I will see you all tomorrow at 1. Bye.